Hello friends, I'm Pavitra Kumbargod. Welcome to my channel. So in this session we will learn some problems on Leibnitz rule. So in the last session I told you about the Leibnitz rule. So Leibnitz rule is finding the nth derivative for the product of two functions. If I consider u and v are any two functions, then the nth derivative of u and v, u into v is u into vn plus nc1 u1 vn minus 1 plus nc2 u2 vn minus 2 plus and so on plus un v, right? So you know the formula for NCR, so you have to remember nc1 is equal to n, nc2 is equal to n into n minus 1 divided by 2 factorial, nc3 is equal to n into n minus 1 into n minus 2 divided by 3 factorial. So let us solve some problems. So here I have considered the first problem. If y is equal to sine hyperbolic m into sine hyperbolic inverse x, you have to establish the relation connecting yn plus 2, yn plus 1 and yn. So see here it contains, means we should establish the relation of yn plus 2. So that means you have to differentiate the function y with respect to x 2 times, then apply the Leibniz rule, find the nth derivative. Okay, so let us consider the given function as y is equal to, given y is equal to sine hyperbolic m into sine hyperbolic inverse x, right? So differentiating with respect to x, you will get differentiation of y is y1 is equal to differentiation of sine hyperbolic function is cos hyperbolic m into sine hyperbolic inverse x into m is constant. So sine hyperbolic inverse x differentiation is 1 divided by root of 1 plus x square, right? Now, so cross multiply, so you will get root of 1 minus, root of 1 minus x square into y1 is equal to m is constant cos hyperbolic m into sine hyperbolic inverse x, right? So now differentiating one more time, in the LHS you have to differentiate by using the product rule. So that is root of 1 minus x square as it is, differentiation of y1 is y2 plus y1 as it is, differentiation of root of a function is 1 divided by 2 root. So 1 divided by 2 root 1 minus x square into differentiation of 1 minus x square is minus 2x, right? So that is equal to m into differentiation of cos is minus sine, so that is minus sine Hello friends, I'm Pavitra. Welcome to my channel. So this is the second session of Leibnitz Rule. So in this session we will solve some more problems on Leibnitz Rule. So Leibnitz Rule is finding the nth derivative for the product of two functions. If I consider u and v are any two functions, then the nth derivative of u into v is given by, that is u into vn plus nc1 u1 vn minus 1 plus nc2 u2 vn minus 2 plus and so on plus un v. So you know the formula for NCR. So please remember this. NC1 is n, NC2 is n into n minus 1 divided by 2 factorial, NC3 is n into n minus 1 into n minus 2 divided by 3 factorial and so on. So let us take the first problem. If y is equal to sin hyperbolic m into sin hyperbolic inverse x, then you need to establish the relation connecting yn plus 2, yn plus 1 and yn. So it contains yn plus 2, so therefore differentiate the given functions 2 times, then apply Leibniz rule, find the nth derivative, will get the relation. So consider the given function as y is equal to, given y is equal to sin hyperbolic m into sin hyperbolic inverse x. So differentiating with respect to x, differentiation of y is y1 is equal to differentiation of sin hyperbolic is cos hyperbolic m into sin hyperbolic inverse x into m is constant. So sin hyperbolic inverse x differentiation is 1 divided by root of 1 plus x square. Okay. So now cross multiply, so I will get root of 1 plus x square into y1 is equal to m is constant cos hyperbolic m into sin hyperbolic inverse x, right. So now differentiating one more time. So in the LHS you have to apply the product rule. So that is root of 1 plus x square as it is. So differentiation of y1 is y2 plus y1 as it is. Differentiation of root of 1 plus x square is 1 divided by 2 into root 1 plus x square into 1 plus x square differentiation is 2x, right. So that is equal to m is constant, differentiation of cos hyperbolic is simple sin hyperbolic, not the negative sign. So sin hyperbolic m into sin hyperbolic inverse x into m is constant. So differentiation of sin hyperbolic inverse is 1 divided by root of 1 plus x square, right. So now here 2 get cancelled. So this 2 get cancelled. So now take the LCM. So root of 1 plus x square is the LCM. Then if I multiply here, root of 1 plus x square into root of 1 plus x square is 1 plus x square into y2 plus x into y1 divided by, so LCM, so that is root of 1 plus x square. So that is equal to m into m is m square. So m into m is m square. Then again sin hyperbolic m into sin hyperbolic inverse x is y divided by, so that is given y is equal to sin hyperbolic m into sin hyperbolic inverse x. Therefore, I have taken it as a y. So, divide it by root of 1 plus x square, right. So, this root of 1 plus x square, root of 1 plus x square get cancelled. So, I will get the equation 1 plus x square into y2 plus x into y1 minus m square y is equal to 0. So, now apply the nth derivative. I will write one more step here. So, 1 plus x square into y2, the nth derivative, plus x into y1, nth derivative, minus m square into y, nth derivative. So, that is equal to 0. So, now apply the Leibniz rule. So, first function, you should take the polynomial as a first function. So, that is 1 plus x square as it is, right. So, nth derivative of y2. So, already we have differentiated 2 times. N more times I have to differentiate. So, that will be yn plus 2 plus differentiation of 1 plus x square. So, NC1 is n. Differentiation of 1 plus x square is 2x, right. So, n minus 1th derivative of y2. So, that is yn minus 1 plus 2. So, that is yn plus 1 plus NC2 is n into n minus 1 divided by 2 factorial is 2. Differentiation of 2x is 2. Then n minus 2th derivative of y2 is yn plus, now second term, x into y1 nth derivative, x as it is, nth derivative of y1 is yn plus 1 plus nc1 is n, differentiation of x is 1, n minus 1th derivative of y1 is yn minus m square into nth derivative of y is yn. So, that is equal to 0. So, now simplify this function 1 plus x square into yn plus 2 plus take the yn plus 1th term. So, this is yn plus 1th term and this is yn plus 1th term, right. So, that is x is common and yn plus 1 is common. So, that is what you left here 2n, right. In this 2n is left, then here plus 1 into x yn plus 1, then plus in this 3 terms, what is common? This 2 get cancelled, right. So, then multiply n into n is n square minus n plus n minus m square into yn. So, that is equal to 0. Minus n plus n get cancelled. So, we will get 1 plus x square into yn plus 2 plus 2n plus 1 x into yn plus 1 plus n square minus m square into yn is equal to 0. So, this is the solution. So, let us consider the second problem. So, if y is equal to cos inverse of y by b, cos inverse of y by b is equal to log x by n raised to n, then you have to show this. So, let us take the function given cos inverse y by b is equal to log x by n whole raised to n. So if I directly differentiate the function, so it will looks like a complicated. So what I will do, I will write the given function as y is equal to. Okay, first apply the logarithmic property here. What you will get, cos inverse y by b is equal to n into log x by n, because log x raised to n is n into log x, right? So apply that property. Then write y by b is equal to cos n into log x by n, right? So now y is equal to b into cos n into log x by n, right? So now differentiate. So differentiation of y is y1 is equal to b into differentiation of cos is minus sine n into log x by n, right? Into n is constant, differentiation of log x is 1 by x, that is 1 divided by x divided by n, into differentiation of x by n is 1 divided by n, because 1 by n is constant, differentiation of x is 1. Now this n get cancelled. So simplify this. If I want this x, if I multiply here, so that is x into y1 is equal to minus n into b sine n into log x by n, right? So now again differentiating, apply the product rule here. X as it is, differentiation of y1 is y2 plus y1 as it is, differentiation of x is 1 is equal to minus n into b is constant. So differentiation of sine is cos n into log x by n into differentiation of log is 1 divided by x by n into differentiation of x by n is 1 divided by n, right? So n is there, so n into, so n is constant here. So this n get cancelled. So now x you have to multiply here, x into xy square plus y1 is equal to minus n square, right? So b into cos n log x by n is y, right? So here y is equal to b into cos n log x by n is y. So now simplify, x into x is x square y2 plus x into y1 plus n square y is equal to 0. So now this function you have to differentiate n times. So I'll write one more step. So that is x square y2 the nth derivative plus x into y1 nth derivative plus n square y the nth derivative, so that is equal to 0. So now apply the Leibnitz rule. So now first x square as it is, nth derivative of y2 is y n plus 2 plus nc1 is n, x square differentiation is 2x, right? Sorry, one second, I'll write. So the pen problem. Okay. x square differentiation is 2x. N minus 1th derivative of y2 is yn plus 1 plus nc2 is n into n minus 1 divided by 2 factorial is 2, differentiation of 2x is 2, n minus 2th derivative of y2 is yn. So next differentiation of 2 becomes 0. So therefore I am not writing the next term. Okay, then plus next x into y1 nth derivative. X as it is, nth derivative of y1 is yn plus 1 plus nc1 is n minus 1th derivative of y1 is yn. So differentiation of x is 1. Okay, so now next term plus n square is constant, nth derivative of y is yn. So that is equal to 0. So now simplify this term. Here 2 get cancelled. Right. So now take the common terms and simplify. So you will get x square yn plus 2 plus now n plus 1th term. So this is n plus 1 and this is n plus 1. So what is common? X into yn plus 1 is common. So what you will get? So in the first term 2n remains. In the second term no remaining, plus 1 into x into yn plus 1. Right. Now plus now in the next term. So this term and these two terms. So now yn is common. So n into n is n square minus n. So here plus next term is n. Then in this plus n square into yn is equal to 0. So now here plus n minus n get cancelled. So write one more step. X square into yn plus 2 x square into yn plus 2 plus 2n plus 1 x into yn plus 1 plus n square plus n square is 2n square. So I have to write 2n square. N square plus n square is 2n square into n square yn is equal to 0. So this is the required result. You see here x square into yn plus 2 plus 2n plus 1 x into yn plus 1 plus 2n square into yn. So you got the same result here. Right. So thank you for watching. Please like, share, comment and subscribe to my channel. Thank you. Thank you so much.